One of the interesting problems that people have solved is finding the power series of 1 divided by 1 plus x. And conventionally, it's done either by using a Taylor series or by merely just doing a division. The division on the right is the one we conventionally see, and there are some problems that occur with this when we try to apply it. However, if instead of dividing by 1 plus x, we divide by x plus 1, which is the same thing, implying that x is greater than 1 in the second case, we get a different power series. A lot of fuss is made over the series on the left. It does not represent 1 over 1 over x for values of x greater than or equal to 1. We show that by introducing another series that represents 1 over 1 plus x, but this series does represent 1 over 1 plus x for values of x greater than 1. This way we can have the whole range of x covered by both series. Let us take and calculate the sum of an infinite geometric series. This can be written as a plus a times b, a multiplicative term, which we keep multiplying each term in the series after that. And if we sum that up, we would find that it's equal to the first term a times the series multiplier b to the nth power, the number of terms in the series, minus 1 divided by b minus 1. We can calculate that by a mere trick of taking the first series, multiplying it by that multiplier b, subtract the two series, and then we get a formula for the sum, which can then be finally written as a times b to the n minus 1 divided by b minus 1. Our series follows that work. But before we try this series, let's check it. First, we check it with a is equal to 1 and b is equal to 2. And then we check it with a is equal to 1/2 and b is equal to 1/2. And when we do that, we find the direct sum of the series is equal to the same as the formula. To give ourselves a little bit more confidence, let's just do this in a general form, where we have a is equal to 1 and b minus x, and a equal to 1 over x and b equal to minus 1 over x. And if we put those values in for a and b, we get back our original series. This is one of the secrets to math and giving us confidence to try something 2 different ways. Now we find that in further analysis, that if we were to put minus 1 in for x, we would get infinity. Both series will diverge using minus 1. However, if we use 1, we find that we get a fluctuating series between 0 and 1, depending upon whether n is odd or even. However, if x is allowed to approach 1, the series will converge to 1/2, but very slowly, noting that if we put a very small value in for x that's close to 1, like 0.999, that raised to the infinite power will eventually approach 0. So we have shown by a little subtle of creativity, by just recognizing that we could divide by the 1 or by the x instead, getting 2 different series, and those 2 series encompass it. This sort of illustrates how we discover things in mathematics. We see a pattern, we try to take advantage of that pattern, and then after we find that pattern, we have to prove that it works. And we do that by giving ourselves some confidence by putting numbers in the formulas that are created, and then trying to show that one apparent series is equivalent to another. The reason why I've done this is because I've seen a number of people who discuss this who do not discuss the second series and go through all sorts of mathematical manipulations to try to explain how just the first series is sufficient. Thank you very much for your attention.